y equals 2 over x plus 1. So I want to take the derivative of this using the quotient rule. So the quotient rule is if I have f over g, I take the derivative, I'm going to be taking the derivative of the first function, f, times g minus g prime times f over g squared. So the top part of the fraction, the numerator, is our f, and the bottom is our g. So we're going to say 2 is f, g is x plus 1. So when I take the derivative, I'm going to be taking the derivative of 2, which is 0, times g is x plus 1, minus the derivative of g, well, that's just 1, since the derivative of x plus 1 is 1, times f is 2, all over g squared. The 0 is going to cancel out the first term, and I'm going to be left with negative 2 over x plus 1 quantity squared. Next, I have y equals x squared over 3x minus 1. I'm going to label x squared as f and 3x minus 1 as g. I want f prime times g minus g prime times f over g squared. The derivative of f is 2x, g is 3x minus 1, minus, now the derivative of g is 3 times f is x squared, all over g squared, which is 3x minus 1 quantity squared. I can simplify this further by distributing out the 2x to both the 3x and the negative 1. 2x times 3x is 6x squared minus 2x, and then we have minus 3x squared all over 3x minus 1 quantity squared. 6x squared minus 3x squared will be 3x squared. And then we have minus 2x over 3x minus 1 quantity squared. And at this point, we can just leave it as is. Next, I'm given f of x is equal to 4x cubed minus 7x all over 5x squared plus 2. F is going to be 4x cubed minus 7x. G is going to be 5x squared plus 2. So I want f prime g minus g prime f over g squared. The derivative of 4x cubed minus 7x is 12x squared minus 7. We're going to multiply that with g, which is 5x squared plus 2, minus the derivative of 5x squared plus 2 is 10x times 4x cubed minus 7x all over 5x squared plus 2 squared. I'm going to FOIL this out. So the 12x squared with 5x squared, 12x squared with 2, negative 7 with 5x squared, and negative 7 with 2. So that's going to be 60x to the 4th minus 35x squared plus 24x squared minus 14. And then distribute out the negative 10x. We have minus 40x to the 4th plus 70x squared all over 5x squared plus 2 squared. Okay, we have 60x to the 4th minus 40x to the 4th. That's going to be 20x to the 4th negative 35x squared plus 24x squared is negative 11x squared plus 70x squared is 59x squared. And that leaves us with negative 14 all over 5x squared plus 2 squared. And it doesn't simplify it any further. Y is equal to 4 times sine x over 2x plus cosine x. We'll let f be 4 sine x and g 2x plus cosine x. The derivative of f is 4 cosine x. So just to recall, this is our formula. So the derivative of f is 4 cosine x times g minus the derivative of 2x plus cosine x is 2 minus sine x. Here we have to be very careful to factor out the g prime. So this negative will distribute to both the g prime and the f prime. Actually, sorry, not g prime, f. It's going to distribute to one of them. But in this case, you want to be careful to put it as parentheses. So think of it as this. Just think of it like this. So you won't run into any issues. Then times f is 4 sine x all over 2x plus cosine x quantity squared. I'm going to distribute out the 4 cosine x to get 8x cosine x plus 4 cosine squared minus, so I'm going to keep the minus out and I'm going to work distributing out the 4 sine x. So that'd be 8 sine x minus 4 sine squared all over 2x plus cosine x squared. Okay. Let's see what simplifies. I have 4 cosine squared minus negative 4 sine squared. So that's the same thing as 4 cosine squared plus 4 sine squared, which I can factor out the 4. I get cosine squared plus sine squared. This we know from trig is 1, so 4 times 1 is 4. So that's going to be replaced with 4. And then I could just leave the 8x cosine x by itself with the minus 8 sine x. And if I really wanted to, I could factor it out, the 8. So I guess we could just leave it as 8 times the quantity x cosine x minus sine x plus 4 all over 2x plus cosine x quantity squared. And that's my derivative. Y is equal to 7x squared all over 4 times e to the x minus x. I'm going to let f be 7x squared, g be 4 times e to the x minus x. I'm going to use f prime g minus g prime f over g squared. The derivative of f is 14x times g minus the derivative of g. Well, e to the x is e to the x, so that would be parentheses. So here, again, be careful with the parentheses. 4 e to the x, and then minus 1 times f all over 4 e to the x minus x squared. I'm going to distribute out to 14x. So 14 times 4 is 56, and that's x e to the x minus 14x squared minus, now let's worry about FOILing out these two, or distributing out these two, and we'll worry about the negative after that. So 4 times 7 is 28, and that's just x squared e to the x minus 7x squared over 4 e to the x minus x squared. Now we can simplify this further, paying attention to negative 14x squared minus negative 7x squared. So that would be, well, let's keep 56x times e to the x, and we'll leave 28x squared e to the x. And so we'll have minus 7x squared all over 4 times e to the x minus x quantity squared. And if we want, we can do some factoring of 7x. So we'll just go an extra step here. They all have a factor of 7x, so we're going to pull that out. So let's see, 7 times 8 is 56, and then we're going to have e to the x minus, well, 7x times 4x is 28x squared, and then we'll have e to the x, and minus x all over 4 e to the x minus x squared. And that's our derivative. Last one, g of x is equal to 1 plus natural log x all over x squared minus natural log of x. I'm going to let f be 1 plus natural log x and g be x squared minus ln of x. I'm going to use the quotient rule, which will be f prime g minus g prime f over g squared. So the derivative of f is 1 over x, because the derivative of natural log x is 1 over x, and the derivative of 1 is 0, times g, and then minus the derivative of g. So derivative of x squared is 2x, and derivative of ln of x is 1 over x, times f all over g squared. Next step, I'm going to distribute out the 1 over x, and I'm going to FOIL these out. So that's going to be x minus ln of x over x minus, and then I'm going to put a parentheses now to FOIL it out. I get 2x plus 2x ln of x minus 1 over x minus ln of x over x all over x squared minus ln of x squared. Okay, we can go a little further. Notice we have x minus 2x. That will be negative x. And negative ln of x minus negative ln of x cancels each other out. So I have minus 2x ln of x plus 1 over x, right? Because this negative is going to distribute out to these two terms. And that's all going to be over x squared minus ln of x squared. And that should be good enough.